Hi, this is Mr. Govern. We are in the 10th video of the electric circuit series in what I call electrical Sudoku. So Sudoku is a game you may have played online or on paper, but in Sudoku you're trying to fill in all the columns and all the rows. You use information horizontally to fill in the horizontal and vertically, and you can use combinations of information in the up and down and the across to solve everything. And that's sort of how I think of solving these circuits problems, and effectively it solves to every single value in an electric circuits problem. So the equivalent of Sudoku in electricity is we want to find the totals of everything, and we want to find everything for bulb A and bulb B, and then we can find voltage, current, resistance and power. And so you can see just like in Sudoku there are values missing horizontally we have to figure out, and values missing vertically we have to figure out. Here we can work horizontally to work out missing values, or we can work vertically to work out missing values. So the rules are just as I've explained earlier: use an IV diagram, then draw your table with what you just saw on the slide previous. If you have two columns, if you have a column and it has a couple of values, you can use a formula to work out a further value. And if you have rows with a few values, you need to obviously work out missing values. You can use your IV diagram after that. And effectively what you want to do is you want to go back and forth between your IV diagram and your table. So let's just go into an example and hopefully it makes sense. So let's say I'm given this situation here with a simple circuit, and I'm given some information about bulb B, and I've been asked to work out all the resistances, all the powers, all the currents through the whole circuit. So the first rule was draw yourself an IV diagram. This is already set up because the battery's at the top, the bulbs are on the bottom, so the IV diagram is square and square beside each other. Then draw my table. So I fill in totals, bulb A, bulb B. If you had a bulb C and D, you can add those on there as well. And V, I, R, and P. So my total voltage is 12. That's what it says here. And I have some values for B. And there we go. All right. So when I have some information on the table, I should try and put it on my IV diagram. That might be helpful, right? So I know my total voltage is 12. So that's my total width of my IV diagram. I've also been given that my bulb B has a width of 8 volts, and so therefore the width of A must be 4, because 4 plus 8 equals 12. So now I've got some information for bulb A. So see how I've taken my information from my diagram, put it on my IV diagram, and then figured something else, put it back on here. So now I've filled in a whole row of voltages. Let's work with a column now. So I've got 2 bits of information. That means I can use a formula to work out another piece of information. Okay, so the formula is V equals IR. And in a previous video when I explained about Ohm's law, I always said use subscripts. There's so many voltages floating around here. You don't want to put the wrong one in the calculation. So you want to make sure that when you're using this, you're only using the values from B to work it out. So I'm missing the current of B. So let's work that out. The current of B is rearrange V over R, put my values in, 8 over 20, and that gives me 0.4. So I can put this in here, 0.4. Now, I've filled in something in the table. What I should do is I should go back and forth between my IV diagram. So now I'm going to, first of all, I can fill out the last little piece of this puzzle here, because I can work out power, the last one. So that is V over I. Again, I've labeled things with subscripts, and put my values in. 8 times 0.4 gives me 3.2. All right. Now I'm going to say, I know this value here, so I'm going to put it back on my IV diagram. Hey, the height of B is 0.4, but that's also the height of A, so I can fill that in. Hey, that's also the total height as well, so I can fill that in as well. So I'm going back and forth between table and IV diagram, just filling in things, just like Sudoku, trying to finish everything I can. All right, now in these columns, I have 2 bits of information. Maybe I can get a third by using a formula. So let's work out with bulb A. I'm using Ohm's law, so I've put subscripts so I know only to use the bits of information from bulb A. I want to find R, so I rearrange it, V over I, put my values in, and it gives me 10 ohms. So fill that in. Alright, it is the last one in that column is the power. Again, I label things with subscripts. 4 times, I've got my current of 0.4, is 1.6, and fill that in. Now I'm going to go, I think I'm going to go crosswards. So I want to work out my total resistance. I could if I wanted to use a formula, but I also know that in series, resistors 1 and 2 just add to give the total. That's an easy one to do. 30 ohms. Okay? And then my last one is my power. What I'm going to do is, I know in any circuit, series or parallel, the powers just add up. So I'm just going to add them to give my total, 4.8 watts. Now here's the check. I use the information from the rows to work out this total power. Because it's my last bit of information, I could use as a check some information from the columns to see if I get the same answer. So what I'm going to do is I'm going to say P equals VI, and this time I'm using the totals column. My total is 12 volts, my total amps is 0.4. Multiply those together, it still gives me the same answer. So just in Sudoku, where you can check your rows and columns, make sure it all works out, you can do the same thing in this. Now, in the next video, I'm going to do an exam question, and this is how I often answer them. They'll give me a circuit, and they might only ask me for something in bulb A, but I'll just sit down, and it only takes about 3 or 4 minutes, just work out every single thing. So I've got all my bases covered. It just makes life a lot easier. So you'll see me do it in the next video when I go through an NCEA problem.